Number 1, A, find f prime of x. F prime of x is, we're going to use the power rule, so we're going to take 3 and multiply it times negative 2, and that's going to give us negative 6x, drop the power. 2 times 4 is going to give us 8, drop the power, so 2 minus 1. The power on the negative 5x is a 1, so it's just going to become minus 5, and then the derivative of 1, because it's a constant and has a slope of 0, will just be 0. So now the domain of f prime of x. F prime of x is a parabola, so its domain is just going to be all real numbers. The tangent line, well, we're looking for the tangent line at negative 112, so we need to take the negative 1 and plug it into our derivative. So here we go. We're going to say f prime of negative 1 is negative 6 times negative 1 squared plus 8 times negative 1 minus 5 is negative 19. So now we know that the tangent line is going to be y minus y1 equals m times x minus x1. Well, minus x1 minus negative 1 becomes plus 1. Letter D, find the points where the tangent line is horizontal. So when the tangent line is horizontal, that means that the derivative is 0. Because remember, the derivative equation gives us the slope of any point, the slope of any tangent line on the point on f of x. So if my derivative is 0, that means my tangent line is horizontal. So let's get out the calculator. So when I graph this on my calculator, we can see that this parabola opens down and it has no x-intercepts. Because my parabola has no x-intercepts, that means it is never 0. So points where the tangent line is horizontal, the answer is just going to be there are none, because the derivative is never 0. Okay, number 2. So f prime of x is going to be, already has that. Is going to be 10x minus 4. Now, this is just a line, so the domain is going to be all real numbers. Our tangent line, we need to find f prime of 4. So that's just going to be 10 times 4 minus 4 is going to be 36. So my tangent line is going to be y minus y1 equals m times x minus x1. Now, points where the tangent line is horizontal, this is a pretty easy one to set equal to 0. We're just going to say 10x minus 4 equals 0. We're going to add 4, divide by 10, and we'll get x equals 0.4 or 5/4. So now we're just going to plug that into f of x into the original equation to find out what the y value of the original equation is. I'm going to grab my calculator and put that in. And I get 1.2. So the point where my tangent line is horizontal is going to be 0.4, 1.2. Number 3. Now, the first thing I'm going to do for number 3, before I even start the derivative, is I'm going to rewrite f of x so that it's written as coefficient times x to a power. So the coefficient is just 1, and the power is going to be negative 2. And the reason I'm going to do that is that way I can apply the power rule. So f prime of x, drop the 1 times negative 2 is negative 2. X, and then negative 2 minus 1 is negative 3. And that gives me negative 2 over x to the third. Now, I can't divide by 0, so anytime x is 0, my derivative will not be defined. So my domain is going to be all reals. X is not equal to 0. Now, for our tangent line, we need to plug 2 into our derivative equation. So let's find out what f prime of 2 is. So negative 2 divided by 2 cubed is negative 2 divided by 8, which is negative 1/4. So now I know my tangent line is going to be y minus y1. Oh, that's a 1/4. Kind of came out bad. Equals m times x minus x1. All right, points where the tangent line is horizontal. So let's put it in our calculator. Okay, so you can see I put it in my calculator, and I have a rational function that has an asymptote at y equals 0. So point where the tangent line is horizontal is once again going to be none. Because this graph never touches 0. If you think about it, negative 2 can never be divided by something that would give you 0. Four. So the first thing I'm going to do for number 4 is I'm going to rewrite it again so that it's coefficient times x raised to a power, specifically for this term here, this root x. The rest of them, they're fine, but I need to think about the root x as 1 times x to the 1/2, because now it's going to be 1/2 x to the negative 1/2, because 1/2 minus 1 is negative 1/2, and then I can just apply the power rule for the rest of them. And then minus 8x, and the 1 just becomes 0. So the domain for f of x, well, I think let's get a graph of this. Okay, so here's the graph of my derivative, and you can see that it starts here at 0 and then goes forward. So my domain is going to be x is greater than 0. I know it's not equal to 0 because this negative 1/2 is really like, let's see if I can squeeze it in, 1 over 2 root x, and I can't divide by 0, so I can't have x be 0. So my domain for the derivative is going to be x is greater than 0. Now for the tangent line, I need to find out what f prime of 1 is, and since I already have it typed into my calculator, I'm going to go look at my table, and I see I have a slope of negative 4.5 at 1, so my tangent line is going to be y minus y1 equals negative 4.5. And again, I already had that typed into my calculator, so I just went and looked on the table. Now, points where the tangent line is horizontal is going to be this point right here on my graph. So I'm going to use, on my calculator, I'm going to go second calc, and I'm going to pick number 2, the 0 command. And I know what it's between. It looks like it's between 2 and, we'll say 4. It's about 3. And my calculator gives me a 0 of x equals 2.63. That's a rounded value. It's actually 2.6275352. And so now what I need to do is go plug that back into my function. So I'm going to do that on my calculator also. Okay, so I did that on my calculator, and when I plugged in 2.63 to the original equation, I got approximately negative 8.85. So points where the tangent line is horizontal is going to be 2.63, comma, negative 8.85. Okay. Number 5. Okay, so the first thing I'm going to do once again is I am going to rewrite this so that it looks like coefficient times variable raised to an exponent. And I only need to do that for this first term because the rest of them look good. So now negative 3 times 1/2 is going to be negative 3/2 x to the negative 4 plus 3. And probably a better way to write that would be f prime of x equals negative 3 over 2x to the 4th. and then plus 3. Okay, the domain of this is going to be something strange because I can't have x equals 0. I'm pretty sure that it's just going to be all real numbers, x can't be 0, but I'm going to double check by graphing the derivative on my calculator. And I need that for letter D anyway, and it would be helpful for letter C, so I can just put -1 in. So let's get a graph of this. Okay, so here's the graph of my derivative function, and I can see that I was right. I have a vertical asymptote at 0, but everywhere else there appears to be an x value. So my domain for the derivative is going to be all real numbers, x is not equal to 0. Now for my tangent line equation, again, I already have the derivative typed into my calculator. I need to know where we are at 1, or I'm sorry, -1. So I'm going to go look at -1. On the table, I have a slope of 1.5. So my tangent line is going to be y minus y1 equals m times x minus x1. Points where the tangent line is horizontal. So now I know I need to just look here and here for my zeros. So I'm going to go and calculate those on my calculator and see what I get. So second trace 0, and I think the one over here is between about, I'm going to say -2 and -0.5. And the first x-intercept I get is -0.84. It's 0.8408964, but I'll just leave it as 0.84, -0.84. If I had to guess, I bet the one on the other side is positive, but let's just double check. Yep, it's positive 0.84. So now what I'm going to do, because this is kind of a pain in the butt equation, and these are, that was F4, supposed to be a 4, but it became a 5. Now what I'm going to do is I'm going to put this original equation again back in y1 because I need to know what the y values are here. Okay, so I went on my calculator, I typed this original equation in y1, I set my table, I went to second window to the table set and made my independent variable ask, and when I did that, I entered -0.84 and got 1.64, I'm rounding that to 2 decimal places, and for positive 0.84, I got 8.36. So my 2 points where the tangent line is horizontal is going to be -0.84, comma 1.64, and positive 0.84 and 8.36. All right, last problem, number 6. Now this one's lovely. It's kind of a nice way to end the problem set because they are all, it's polynomial. So -4 times 4 is just going to be -16. Drop the power. 3 times 3 is 9. Drop the power. 2 times 2 is 4. Drop the power. And -1 x just becomes -1. This is just a cubic function. Its domain is all real numbers. For my tangent line, I am going to grab my, let's see, I don't even need to grab my calculator. This one's easy peasy. If I put 0 here, I get 0. If I put 0 here, I get 0. If I put 0 here, I get 0. So the slope is just going to be -1. And I don't even, y minus y1 is just going to be y minus 0 equals -1. And then x minus 0 is just x. So fast. So now let's put our derivative equation into the calculator and see where our tangent line is horizontal. Okay, so you can see now that I have my graph up, I've got 3 x values, 1, 2, 3. And now I'm going to go use my calculator and I'm going to find the zeros. What are these 3 zeros? Okay, so I used the second 0 function on my calculator and I found that this first 0 here is -0.41. This one that I thought was kind of close to 0 was pretty close to 0. It was 0.19, and then the one on the right is 0.78. So now what I'm going to do is I'm going to enter the original function into my calculator right here, and I'm going to set my table to ask so I can easily enter these 3 values and have it give me back those y values. Okay, so when I entered -0.41, I got 0.43, When I entered 0.19, I got negative 0.10. It was actually, these are all rounded to 2 decimal places. And when I entered 0.87, I got 0.38.